Hello! In this video, we are going to walk through the activities from day 5 of the Beginning Python Challenge where we put all of your learning together. We're going to use loops, functions, and variables to draw shapes with the Python turtle. First of all, I want to congratulate you on progressing to day 5. In day 4, we made our triangle drier using a function and introduced a square function. Today, we're going to integrate this newfound knowledge by creating general purpose polygon and spiral functions. So if you don't have the day 4 code up, on the activity worksheet, we have the same code available here. We observed last time that the triangle and square functions were very similar. And so what we want to do is make that drier and remove the repetition by putting them together in a single, more generalized polygon function. So I'm going to start with triangle, and I'm going to simply call it polygon. And what I want to figure out is what needs to change to allow a general purpose polygon. First of all, in the directions for step 2, I can see that I need to take, in addition to the length of each side, which I already have here with size, I also need to take the number of sides. So I'm going to add an additional parameter to stand in for the number of sides that I'm drawing. And I can see as I read through this function, with the triangle we had 3 sides. So whenever I see something related to 3, I'm going to replace it with my parameter. So I'm going to say for I in range num, which is now going to be the number of sides of my polygon, and then I'm going to go forward the length of each side. So that doesn't change. Then I'm going to go left, in this case 120. Now that's not the number 3, but it's related to the number of sides. What I need to do, and this is in step 2, is I'm going to take the number of degrees in the circle, which is 360, and divide it by the number of sides. Now, we could improve the dryness of this code a little bit by calculating this once as a variable, but I'm going to keep the code simple and leave it this way at this time. So let's test this out. So I'm going to draw a polygon. Let's see, let's do a triangle, and then I'm going to draw another polygon, and this one we're going to make a square. Oops. There we are. And I'm going to just comment out the square function for now while we're testing the polygon function. So let's see how this works. So I drew a triangle, and now I called the same function, and I drew a square. So now we're starting to see how functions can really scale up our code. So I just took 2 functions and I replaced them with one more general purpose function that accomplishes even more. It's even more reusable. Before I just had the ability to draw triangles and squares of different sizes. Now I have the ability to draw shapes of all different numbers of sides and sizes. So that's a wonderful transition for us. If you have time and the inclination, there's also a challenge aspect to this problem, asking you to print an error message and draw nothing if there are less than 3 sides passed into this function. So I'll leave that to you if you're interested. So now our next step in step 3 is to test that our polygon function works by using a loop to draw multiple shapes. So what I'm going to do is try and draw like a clock of polygons using a loop. So I'm going to comment out my example code for now. I'm going to leave it there as an example so I have some templates to work from. I love writing code from templates. And so I want to create a loop that's going to draw a couple different shapes. So for n for number of sides in range. And I want to start at 3 because I don't want to draw shapes with only 1 or 2 sides because those are just going to be lines. I want to start with a triangle. And why don't we go up through 9? We'll do a 9-sided figure. Okay, so first of all, what I'm going to do is I'm starting in the center, and I want to move a little bit forward so that I can space out my shapes in a ring, in a circle, as you can see on the activity worksheet. So to go forward, I can actually reuse my back function. It's a little bit counterintuitive, but I'm just going to go with it because I want to go with the code that's here. But ideally, I would probably try and create a forward function. In fact, that might actually be a better idea. Let me show you quickly how to do that now. Well, first I'll show you what I was going to write. So I was going to go forward by negative 50. But this really doesn't make a lot of sense. There's a way that we can actually simply improve our code by adding a forward function. We can define a forward. Actually, I'm going to call it move because Turtle already has a forward function and I don't want us getting confused. So this is going to be our forward function. I'll just make a note of it here. So I want to move length. But guess what? I can already use back to go forward. I don't need to implement a brand new function. So what I can do is simply multiply the length by -1 and pass it to the back function. So this is called a helper function. So now my naming will look better. So I'm going to move forward 50 here. And that's much cleaner code. It's much easier to read. But we're still getting to reuse the functionality we've already implemented in back. We've just done it once and we're keeping it. Okay. So then what I'm going to do is I'm going to draw my polygon. And I'm going to move, I think we said, yes, the number of sides is n. And then I just have to pick a size. So for the purpose of this exercise, I might start with a size of 100, but that's going to be a really big polygon. And I'm going to be drawing 7 of them all in a circle. And what'll happen is if I leave it all the same size, they're going to start getting bigger and bigger because if you leave the side length the same, a triangle is going to be smaller or a square is going to be smaller than like a hexagon if the side length is the same. So what I'm going to do is I'm going to actually divide an overall size by the number of sides of my polygon so that overall visually they look about the same. And if you want to experiment with this, which I encourage you to do, you can take out the divided by n to see what I mean and see how it goes. In fact, if we have time, we can do that at the end. Okay, so then I'm going to go back. So I'm moving forward, I'm moving back, I'm drawing my polygon after I move forward, I'm coming back. And then finally, I need to turn to set up to draw the next polygon. So it's almost like I'm going to each symbol of a clock. If you imagine an analog clock in your head, it's like I'm going to each symbol of it and drawing a shape over it instead. So what we can do here is we want to turn like a piece of pie once for each shape. So we're starting at 3, 5, 6, 7, 8, 9. We're not doing 10. That's 7 shapes. So I need 7 slices of pie that I'm going to be turning. So I'm going to divide by 7 here. Okay. And I don't think I need these lines anymore. So let me delete those so we can see the program all at once for us. So we can see the program all at once for us. And now let's run this and see what happens. Awesome. So you can see how I'm going back and forward and I keep coming to a center point of my circle. Awesome, awesome, awesome. And so we can see that our move function is working, our back function is working, our polygon function is working, and then we've set up this loop properly, Now, I did mention that you need to divide the overall size by the number of sides on each shape. Let's take that out for a second, so you can see what happens. And this is going to go off the screen. This is going to be really big. So all the shapes overlap, and they each get bigger and bigger and even bigger. They get really big because each side that we draw is 100. But when we have more sides, we need to draw less. We need less length there. Okay, so I'm going to keep that divided by n in there. Whenever you're reading code, though, that you don't understand, it's always a good idea to play with it, experiment. Nothing can go wrong. Nothing you can do that can't be undone. So you can always try something out and then undo it or change it or modify it, and that's how you learn. You learn by experimenting. Awesome. So we have completed up through step 3 of this challenge. And now there's one more that we have, which is the spiral. I'm going to comment out my code here for this and add a spiral function. So my spiral function is going to take the length of the longest side and the angle of the spiral as parameters. And if you'd like to see an example of what I'm trying to create, you can check out the worksheet on step 4. Okay, so what I want to do is I'm going to want to create a for loop because I want to repeat. I want to go forward and then turn and go forward and turn, but I want to shrink how far I'm going forward. So the length is going to shrink at every time. So I'm going to say something like for I in range, and I'm going to start with length here because I want to start with the length of the longest side. And I want my longest side or my shortest side to be no smaller than 5. Or I could make that 4, something like that. But you want it to be a visible number of pixels. And then in this case, I'm going from a big value to a small value, presumably, because we're probably going to start with like 100 as a side length. So I'm going to go down each time. So my step increment is actually going to be a decrement where I'm going to reduce the length at every repetition of this loop. Okay, and then I'm going to go forward, turtle.forward, and I just go forward I, that's the side length. And then how much should I turn? Well, in this case, it's a parameter, so I get to use the angle that the client who calls my function is going to pass in. Let's test this out by calling it. So I'm going to draw a spiral, and I'm going to pick a side length of 75 and maybe an angle of 45. Let's see how this goes. All right, awesome. And that drew a spiral very similar to the one that is on the activity sheet. Now, remember, the true test of a function is if you can call it this in the same program with different parameters and you get different results that are correct. So we always need to test our functions more than once to really prove that they're generalizable and they're reusable in multiple situations. So what I'm going to do is I'm going to now move over. I'm going to take advantage of that move forward function that I have, and I'm going to make the color blue instead, just so in case they overlap, you can see them. And then I'm going to draw a different spiral with a side length of 100, and I'm turning 90. So this is going to be a square spiral, a little bit different from the spirals on the activity sheet. Let's see what we get. Oh, and now it's drawing the second spiral. Awesome, and there you have it. You have done an absolutely amazing job in these 5 days, in the 5-day beginning Python challenge. And so after really integrating this knowledge and putting it to the test and putting it into practice, I think you're absolutely ready for the next challenge. And I hope you'll join me on that journey and allow me to be a part of it.